Lesson 510, multiplying or dividing decimals. In this lesson, we're going to be presented with some real-world problems where once we visualize the situation and examine the clues and understand what we're being asked to solve for, we're going to need to make a decision about whether we need to multiply or divide. Now, we have been studying in this current unit how to divide whole numbers and decimals. Not so long ago, we reviewed how to multiply whole numbers and decimals. And so we'll be doing a little bit of the old along with a little bit of the new in this lesson. And let's get started. We're going to focus on these problems on this page 4, 6, 9, and 11 through 14. Number 4, we have 35 hundredths multiplied by 8 hundredths. Remember how we think through and solve a problem that looks like this. First, let's count how many places we need to push a decimal point in order to clear it out. Whoop, 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 whoop. If you said 4 places, you are correct. Then we can imagine that the new problem is 35 times 8, knowing that after we solve it, we're going to need to come in 4 places from the end to reinsert the decimal point. 8 times 5 is 40. The 0 will come down. The 4 gets carried. 8 times 3 is 24, plus the 4 is 28. And then come in 4 places from the end. Pew, 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 pew. And we get an answer of 280 ten thousandths. Of course, you could also represent this as 28 thousandths because the extra 0 on the end can be added or removed. Number 6, 17 and 6/10 multiplied by 9 1/10. Let's count how many places we're pushing the decimal point first. Whoop, whoop, 2 pushes. Now we'll solve this as if it's 176 times 91. For the first row, we'll do 176 multiplied by 1. 1 times 6 is 6. 1 times 7 is 7. 1 times 1 is 1. Then, remember how we start that second row. We add that 0 placeholder, and then 9 times 6, 54. 4 comes down, 5 gets carried. 9 times 7, 63, plus the 5, 68. 8 comes down, 6 gets carried. 9 times 1, 9, plus the 6, 15. Bring it on home. Let's add our columns. 6 and 0 is 6. 7 and 4 is 11. 1 and 1 is 2. 2 and 8 is 10. 1 and 5 is 6. And the 1 comes down. Now let's come in from the end 2 places. Pew, pew. We have our answer. Moving on to number 9. We look at this division problem and we see right away that the divisor is a decimal. So let's count how many places we need to push the decimal point to clear it out. Whoop, whoop. And what we do to one side, we must do to the other. Whoop, whoop. So essentially, if I'm imagining a decimal point here and doing 2 pushes, I'm adding 2 zeros, aren't I? Because the imaginary decimal point there was pushed 2 places to the right. Now, I'm thinking about this as my new divisor is whole number 12. My new dividend is whole number 62,400. And we will set out to solve this. Find how many times 12 goes into 62. 5 times. 12 multiplied by 5 is 60. I'm going to write really small here. 62 minus 0 is 2. Let's bring down the 4. Find how many times 12 goes into 24. 2 times. 12 multiplied by 2 is 24. Let's subtract and bring down. 12 goes into 0, 0 times. I'm running out of space, but I think we know how this story is going to end. 12 goes into 0, again 0 times, and there's our answer. 11. The divisor has a decimal, so let's count how many places we need to push the decimal point to clear that out. Whoop, whoop. 2 pushes changes the divisor into whole number 39. Let's do the same over here. Whoop, whoop. Now I can cross this out, cross this decimal point out. Our new dividend is 8,190. And let's set out to solve this thing. Let's find how many times 39 goes into 81. Well, 39 is close to 40, isn't it? 40 times 2 is 80. I'm feeling pretty solid that we're going to be looking at a number 2 right here. Let's do the side calculation to confirm. 39 multiplied by 2. 2 times 9 is 18. 8 comes down, 1 gets carried. 2 times 3 is 6 plus the 1 is 7. 78, that checks out. I'll line my 2 up. We did our multiplication, got 78. Now let's subtract. 1 minus 8. The 1's going to need to borrow. 8 becomes 7. 1 becomes 11. 11 minus 8 is 3. Bring down. The new number that's formed is 39. 39 goes into itself once. To our bring down. 39 goes into 0 times. Multiply that out, subtract. Nothing left over, nothing to bring down. We have our answer. And now for the fun part. The directions say for each problem, decide whether you need to multiply or divide, then solve, and explain how you know your answer is reasonable. This last part, whenever I see the word reasonable, I always think of doing an estimate first. Problem 12 states if there are 14 ice cubes in each tray, for a party the host estimates she will need 215 ice cubes. How many trays will she need? How many ice cubes will she need from the last tray? Okay, so let's visualize the situation. We can picture an ice cube tray. We know that each ice cube tray can hold 14 ice cubes. We're trying to determine how many trays we're going to need of ice cubes to meet the target of 215 ice cubes. I think division is what we are looking at. We're going to divide 215 by 14 to see how many trays are needed. $14 is going to go into 21 how many times? Once. 14 multiplied by 1 is 14. Subtract that out. 1 minus 4, the 1 needs to borrow. 11 minus 4 is 7. Let's do our bring down. And the new number is 75. 14 goes into 75 how many times? Well, I happen to know that 14 times 10 is 140. Half of that, or 14 times 5, is 70. 70 is going to be very close, but not going over. I'm going to put my 5 up there. 14 times 5 is 70. Subtract. And I get my answer of 15 remainder 5. In other words, in order to get 215 ice cubes, I need to fill up 15 trays completely, and I still need an extra 5 ice cubes. So, go back to the question, how many trays will she need? Well, if we say 15 trays, that's close, but not quite enough. We got to round this up to 16 trays. And the second question says, how many ice cubes will she need from the last tray or the 16th tray? She'll need 5 ice cubes from that tray. Okay. $13. Penny gives 1/5 of her earnings to charity. If she earns $90, how much will she give to charity? Round your answer to the nearest penny. Okay. So if she gave all of her earnings to charity, she'd be given $90. She's giving 1/5 of her earnings. So to me, that sounds like multiplication. We're trying to figure out what's 1/5 of 90. Well, that is 1/5 multiplied by 90. Now, remember how we do this. We can rewrite the whole number as itself over 1. This is kind of a blast from the past, isn't it? Do you remember cross-canceling? Looking at the 5 and the 90, trying to figure out how many times the 5 goes into 90? Let's use division. Let's do a side calculation somewhere here to figure that out. 5 goes into 90 once. 5 times 1 is 5. 9 minus 5 is 4. Let's do our bring down. 5 goes into 48 times. 5 times 8 is 40. Okay, so 5 goes into 90 18 times. Therefore, I can divide this by 5. 5 divided by 5 is 1. 90 divided by 5 is 18. Multiply across the top. 1 times 18 is 18. 1 times 1 across the bottom is 1. And I'm going to get whole number 18 as my answer. No need to round to the nearest penny. I've got a clean answer of $18. 14, Chantel bought grapes at 85 cents per pound. She purchased 7 pounds. What was the total cost? Round your answer to the nearest penny. All right. This is the price of 1 pound. She bought 7 pounds. Are you thinking multiplying or dividing? If you said multiplication, you'd be right. So I'll set it up like this. I'll count how many places I need to push a decimal to clear it out. 2 pushes will do it. Solve this as if it was 85 times 7. 7 times 5 is 35. 5 comes down, 3 gets carried. 7 times 8 is 56 plus the 3 is 59. Come in 2 pushes from the end. Pew, pew. Get our answer. $5.95.